Okay, so I wanted to re-record this lesson because on Thursday when we went for our break and we came back, I forgot to hit record again. So I wanted to make sure that you had something to go back to for 5.2. So 5.2, let me share my screen. 5.2 in our OneNote looks like this. So remember, when we're looking at systems of linear equations, when we get into 5.2, if you remember, on Tuesday we talked about 4.1. 4.1 was the systems of linear equations. That is when you have two lines and they cross, what you're doing is you're looking for that point right there. Right? You're looking for the one point where the two lines cross. And remember, we talked about sometimes you have parallel lines, so they never cross. That's going to be a false statement. Sometimes you have the exact same line, and so there's an infinite number of points, and that is when you have a true statement. But most of the time, you have two lines that cross, and you're looking for where they cross. So just a reminder on how to walk through this. We have a system of linear equations. You notice one has a positive 5y, the other one has a negative 5y. That makes it very nice. We can go through and just cancel that. So when you solve this, we cancel the y's, we end up with 3x equals 15. And I got 15 from 20 minus 5. I got the 3x from the 2x plus 1x is 3x. So when you solve this, you divide both sides by 3, I get x equals 5. Okay? Pretty straightforward. The main thing to remember is we're looking for the two lines, where the two lines cross. We're looking for a point. So remember, you have to have a point in the form xy. This is my ordered pair, right? That's the address, if you will, of where the point is, where the two lines are going to cross. So I have to find the y. So I'm going to plug this back in. It does not matter which one you pick. It's your choice. And we solve for y this time. So we get negative 5y equals negative 10. I'm going to divide both sides by negative 5. So I get y equals 2. So my ordered pair that will satisfy, in other words, it's the solution that makes both of these equations true, is the point 5, 2. That's where those two lines are going to cross. So let me prove it to you. If I plug those values into each equation, what I'm asking is this side equal to this side? Is the 2 times 5 plus 5 times 2 equal to 20? Well, you can see they're both 10. So 10 plus 10 is 20. So the point 5, 2 does satisfy that first equation. Now, if that's true, it should satisfy the second equation. So I have 5 minus 5 times 2. Does that equal negative 5? And again, that's what I'm asking myself. Does this solution satisfy both? It has to satisfy both equations. So 5 minus 10, does that equal negative 5? Well, it does. Negative 5 equals negative 5. So both lines are satisfied. What that means is those two lines, that's where they crossed. They crossed at that one particular point. That's when both equations are equal. Okay, so that's your elimination. So now what we're going to get into is graphing. Okay, so you can think of it as steps, but there's a logical sequence of why you're going to graph the way you're going to graph. So when you're graphing and you have restrictions, right? So a restriction is when your values, so the x values have to be greater than or equal to 0. And what that means is we have positive values. The other restriction is when the y values are greater than or equal to 0. So those are also positive values. Now, the reason why there's these restrictions is because when we get into our word problems or our applications, if we're looking for how many, tables and chairs are we needing to build to make a certain amount, you're not going to have a negative number of tables and chairs. Or if you're looking for how many tickets, children's tickets, adults tickets, how many tickets are we going to have to sell? You're not going to sell a negative number of tickets. So that's why everything has to be positive. The values have to be positive. So we have to put in those restrictions. So that's what you're going to graph first. The second thing you're going to look at is my line solid or dashed? So if you have less than and equal to or greater than or equal to, you're going to end up with a solid line. Because what you're saying is the line is part of the solution. It's equal to it, right? So you have your graph is basically divided up into three parts. You have the part above the line, you have the part below the line, and you have the line itself. So there's three things that you want to look at. So if there's an equal sign in your inequality, that line is included, okay? If you have just less than or just greater than, you have a dotted or dashed line. Okay, so that's going to be one of those little things, little details that you want to pay attention to as you're walking through how to graph. And then the next step is you're going to find your intercepts. You already know how to do that, right? You cover one term up, you solve for the other. You cover the other term up, you solve for the other. And that gives you your intercepts. And then you're going to plot the points and draw your line. And then you're going to find out, okay, where am I shading? So C, B, C, D, E, and F, you already know how to do. So E says we're going to use the test point 0, 0. See which, if we have a true or a false statement, and then you're going to shade on the correct side. So this kind of gives you kind of a rundown. If you are consistent, then and you do it the same way every time, then you'll be just fine with this whole section. Okay, so we already found out where these two lines cross. Okay, this is the exact same two. The only difference is now we have an inequality. So this is where, since now we have two lines that we're going to deal with, this is where it's going to be really important to have two different writing utensils, whether it's a pencil and a pen, or two different color pens, or colored pencils. I love the color, so I don't know if it's a girl thing or not, but I like the color. So what I'm going to do is I'm going to use quite a bit of color in this class, or in this section. So my first equation I'm going to do in orange, okay, and I'll write it over here. So I have 2x plus 5y is less than or equal to 20. Okay, so again, I'm noticing that I have less than and equal to. If you notice, there's no restrictions. So you don't have to worry about the restriction unless it's sitting there. If it's sitting there, the x and y greater than 0, then you have to graph that first, okay? If it's not there, you don't have to worry about it. So next step, I notice it's going to be a solid line because of my less than and equal to. And now I'm going to find my intercepts. So I'm going to cover up. So I'm going to do it physically, and then I'm going to show you just, you're going to get so good at this that you're going to do it mentally. So I'm going to cover up the first term, and I get 5y equals 20. Again, notice I'm not worried about the inequality. The inequality symbol is only used to know which way to shade, right or left, up or down, okay? So I can just kind of ignore it for right now until I get to the shading. So on this one, I get y equals 4. Then I'm going to cover up the other one, and I get 2x equals 20. Divide both sides by 2, and I get x equals 10. Okay, now I'm going to rewrite this so that we have all the information. Okay, so there's my intercepts. My x is 0 when y is 4. This one, when x is 10, my y is 0. So remember, whichever one you covered up, that's your 0. Okay, so I covered up the x, so my x is 0. Here I covered up the y, so my y is 0. All right, and that tells me which intercept it is, okay? So now I'm going to come over to my graph, and I'm going to try this. Let me get rid of this one. Okay. So I'm going to come over to my graph and I'm going to create a graph. So here is my Y. Pick up another one. I guess I should have picked up an actual line. Here is my X. Okay. Will we move this whole thing? Will it let me? Oh, it does let me. Come on. Okay. All right. So there's my X and my Y. I'm going to come over here. I have the orange line. I have 0, 4. So I'm going to use each of these as 1. So 1, 2, 3, 4. So there's my 0, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I hope that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay, so there's my X equals 10. And now I'm going to draw my line. Now, if you notice, there's no restrictions. So I don't have to stop it in that first quadrant. Okay, so that's pretty close. So there's my line. Now, to test to see if where I shade, remember, I'm going to go 0 is less than or equal to 20. Now, where does the 0 come from? Remember, the 0 comes from your test point. So what you're literally doing is you're taking the X out and plugging in 0. You're taking the Y out and plugging in 0. And so I get 0 on the left is less than or equal to 20. So instead of doing this whole big step, that's why I like 0, 0. It makes it super easy. The whole left side goes to 0. So now, do I have a true or false statement? Well, 0 is less than 20, so I have a true statement, which means I'm going to shade down here. Okay, that's where my shading goes, is where the 0, 0 sits. Remember, the 0, 0 sits right here. So that means every solution on this side of the line will make this true. Every single one. Okay, so now we're going to do the other line. So notice I am creating my intercepts. I'm noticing, is it solid or dotted? I'm shading, and then I go to the next line. Okay, don't go back and forth between lines. Do one line, shade, then jump to the other line and shade. Okay, so now let's see, move this over just a little bit so I can do the other one. So the other line is X minus 5Y is greater than or equal to negative 5. Okay, so I know I'm going to have a solid line. So just kind of walking through those steps. I'm going to get my intercepts. So when I cover up the X, I make the X a 0. So my negative 5Y equals negative 5. So my Y equals 1. Okay, so let me get this out of the way. So I ended up, how did I get that? Because I had negative 5y equals negative 5, divide both sides by negative 5. Now we're going to get to the point where I'm not going to show you this, right? You should be able to see it. You should be able to just look at it and go, okay, I can get my intercepts really fast. All right. And then this one, when I cover up the y, I have x equals negative 5. So my x-intercept is negative 5. Okay. And again, there's nothing to solve on that part because the x is all by itself. Okay, so I'm going to come over here. I'm going to plot my points. So I have 0, 1, and I have negative 5 on my x. 1, 2, 3, 4, 5. And my line, oops, I'm going to line that goes something like this. And I want it to go through both. It's kind of easier to just draw it than to use the computer lines, but I'm trying to keep them as straight as possible. Okay, and then I shade. So 0 is greater than or equal to negative 5. So again, know your number line is 0 is to the right of negative 5. So 0 is bigger than negative 5. So I'm going to shade down here where my 0, 0 sits. So you can see where the orange and the purple overlap. It's very clear where the orange and purple overlap. So you can see that right down here in this, I'm going to highlight it, right down here in this area. Okay, it includes the lines, right? It includes both lines and then all of these points. Now, how do I know that this is this is the solution set? So when you double shade, right, it overlaps. This is what's called the feasible region. In other words, where it's double shaded, that's where all the solutions are. And all of those points will fit and make both of those statements true. Okay, every single one of them will fit and make both of those statements true. Let me prove it to you. I'm going to pick a point. So I'm going to pick this point right here. So let's see, I'm going to go over 3 and down 1. So I'm going to pick that point right here. Okay, so it's at the point 3, -1. Okay, and it's a random point. I'm just proving to you that all of those points in that region are going to fit. So let's try it. We have 2 times 3 plus 5 times -1. Is that less than or equal to 20? So we have 6 minus 5 is 1. Yes, 1 is less than 20. So it fits for that one. So let's see if it fits for the other one. 3 minus 5 times -1, is that greater than or equal to -5? So 3 plus 5 is 8, and 8 certainly is bigger than -5. Okay, now what that means is every single point in this shaded, double shaded region will all work. Every single one will work. And if you don't trust me, you try it. You plug the points in and see if it actually works, but it will. Okay, so that's the premise, right? That's the difference between 5.1 and 5.2. That's one of the differences. 5.1, you had one line you shaded, you found your intercepts and you shaded it. With 5.2, you're going to have 2 or more lines. And so that's why the color comes in. That's where it's really important for you to have 2 or 3 different writing utensils. Okay, so let's try the next one. Okay, so this is just kind of some general information. We went over it already, so I didn't want to rewrite it again. So, going back to here, remember we already found out, where do the 2 lines cross? Well, the 2 lines cross at the point 5, 2. Remember, we already did it. We already did elimination right up here. Notice I didn't have to do my inequality symbols. It is still, both lines are still there, whether it's inequality or not. So where the 2 lines cross is right here. And that's the point 5, 2. Now, remember I gave you a link for free graphing paper? It helps. It helps tremendously, because if you just do, sketches on regular paper and you're trying to see where the lines cross, the graph paper will give you a more accurate picture than just a random graph that you draw. Okay, so make sure either you go buy it, which I'm not telling you have to, because I gave you where you can get free graph paper. Okay, so where do the 2 lines cross? We did elimination. We found where the 2 lines cross. Now, the feasible region, again, is where all the overlapping happens, right? All the shading happens, and it's got to overlap. So that means that if it doesn't overlap, then there's no feasible region. It's got to overlap. So there's two different types of feasible regions. One is called bounded and one is called unbounded. And with the graph that we just did, this is considered unbounded. It's an unbounded feasible region. And the reason is because that shading will continue down. Okay, it doesn't stop. There's no boundaries there. So it's unbounded. Bounded means that there's like a fence around everything. There's a line, or the restrictions are there. Okay, so it's completely surrounded with boundaries, if you will. Okay, so the reason why that's important is because if you have a bounded region, right, it's completely surrounded, then you can have a minimum and a maximum. Okay, if it's unbounded, that means you can have a minimum, but you can't have a maximum, because the maximum, because the shading is going forever and ever and ever. Okay, so that's the biggest difference, is you have to pay attention to, is my feasible region bounded or is it unbounded? Because in my math lab, it may ask you for the maximum, but if you have an unbounded region, you can't have a maximum. Okay, there is no maximum. So now the other part that's different in 5.2 is now they're going to ask you to find the corner points. So the corner points is where, and I have it highlighted in green, it's where the maximum or the minimum values will always happen. They will always happen at the corner points. So when you look at this, let me make this bigger. When you look at this graph, the yellow is our feasible region, right? It's completely surrounded by blue lines, right? Those are those fence, those are those boundaries. So this is a bounded region, okay? Bounded feasible region. There are an infinite number of points in that feasible region. So what's nice is knowing that when I have a corner point, that's where the maximum or minimum happens, right? If I didn't know that, then I would have to test every single point to see which one will give me the maximum and which point will give me the minimum. So what it does is it limits how many times I have to test, how many times I have to look at points. I just have to look at the corner points. So what are the corner points? Well, the corner points are where the lines cross, and it will only be around the feasible region. Okay, so that's a corner point. That is a y-intercept. That's a corner point. That's your 0, 0. This is a corner point. That's your x-intercept. This is a corner point, which is where the two lines cross. Okay, now this is a great example because there's no color. So if I said, okay, the two lines are crossing here, well, how do I know which two lines they are? Because we're going to have more than just two lines. We're going to have 3 and 4, sometimes 4 lines that you have to graph. So that's where the color comes in. It helps you keep track of which intercepts are you looking at and which two lines are crossing. Okay, so those are the corner points. All right. And it's only around the feasible region. So in other words, this point right here, that is not on the feasible region. Okay, so that is not a corner point. This one right here is not a corner point. It's got to be touching the feasible region. Okay, and it's got to be where two lines cross. This one right here, the two lines that are crossing is the y-axis and this line right here. This line is the x and y axis. These two lines is the x-axis and this line right here. And then this point right here is where those two lines are crossing. Okay, so that's what the corner points, that's where they sit. All right, okay, so here we go. So with this one, and I'm going to make this bigger so that we can graph it easier. Should have done that in class. Okay, with this one, and again, I'm gonna use my different colors. So first things first, I notice I have your restrictions, right? This is the everything's positive restrictions. So even on your paper, remember you're doing this on paper first. If this was a question in my math lab, I would look at it, I would write it on and graph it and shade it on paper. And then I would answer the question in my math lab. Don't just go right to my math lab, because my math lab is very picky with how you graph it. All right, so here we go. I'm going to put in my restrictions. So here's my restrictions. Oh, I didn't like that. Oh, won't it move? There we go. Nope. Huh. All right, I don't like that. I'm just gonna draw it. So you're gonna have to put up with my terrible drawing. All right, here we go. So here is my x is greater than 0. Here is my y is greater than 0. Okay, what that tells you is that this doesn't matter. Those are completely oblivious to what we're doing. Okay, all we care about is that our x's are positive and our y's are positive. So we're only dealing in this first quadrant. Okay, so now I'm going to change my color and I'm going to draw this equation. So again, I look and I go, okay, I have a solid line, right? So I did my restrictions, solid line, because I have less than and greater to, less than or equal to, excuse me. And now I have to find my intercepts. So now I'm not going to show you the how do I solve, right? You're just going to look at it. So we're going to cover up the x. That means the x is 0. So I'm covering up the x. My y is 6 divided by 3, which is 2. Then I'm going to cover up the y. Okay, I'm going to cover up the y, and I end up with x is 6. So 6, 0. So this is my y-intercept. This is my x-intercept. Okay, so I'm going to come over here. I'm going to put a point at 0, 2 and at 6, 0. Should have used a different color. And then again, forgive my terrible lines. Okay, that's not bad. All right. And now I'm going to do my test point. 0 is less than or equal to 6. This is a true statement. So I am going to shade it. I'm going to try it this way. So remember, I'm shading, but I'm staying in the first quadrant. So it includes the line and the blue feasible region. Okay, so now what's my corner points? Well, the corner points, I already have them. This one I don't even have to calculate anymore. I always have 0, 0. Don't forget that. In my math lab, it'll mark it wrong if you don't have 0, 0. So 0, 0 is a corner point. My y-intercept is a corner point, and my x-intercept is a corner point. So I don't have to do any more calculations, right? I only had one line, and I know what my intercepts are, so I'm good to go. Okay, it's also bounded. So my restrictions, the green, takes care of the boundaries there, and then my solid blue line takes care of the boundary on the upper part. Okay, so it is bounded. It's completely fenced in, that region. So it's a bounded feasible region, which tells me, so I'm going to keep saying this, which tells me I can have a minimum and I can have a maximum because it's bounded. Now, what is it? We don't know yet. We'll get there. That'll be in the next section. Okay. All right, here we go. Here's another one. Now, if you notice, now I have 2 lines. I have my restrictions and I have 2 lines. So I need to get rid of this. So I need to, oh, come on. I need to use my color. So I'm going to use orange for this one. Okay. I'm going to make sure that my boundaries my restrictions are filled in. So the first thing I'm going to do is put those restrictions in. So I'm going to put my y, or my x is greater than 0, and my y is greater than 0. I don't know why it does that. Okay, so again, the other 3 quadrants don't matter. All I care about is that first quadrant. So that's done. So now I can look and I go, okay, I have a solid line. My inequality is x plus y greater than or equal to 3. My intercepts Cover up the x, my y is 3. Cover up the y, my x is 3. So I'm going to come here. Do you see how fast I'm doing this? You're going to get this fast, I promise. You just have to keep practicing and keep doing it in the exact same pattern. All right? Okay, so here we go. There's my line. Connect the dots. I'm going to use my test point. 0 is less than or equal to 3. That is a true statement. So I'm going to shade down here. Okay? Now I'm going to use a different color. I'm going to use green. No, not green. I'm going to use dark blue. Okay, so I'm going to use the dark blue for this one. So this is a solid line because it's less than and equal to x plus 2y less than or equal to 4. Cover up the x. I have 2y equals 4, so y is 2. Cover up the y, and I get x is 4. So I'm going to come here, 0, 2, 4, 0. There's my line. Use my test point. 0 is less than or equal to 4. That is also a true statement. So I'm going to shade below. Okay, now notice where the double shading is, right? The double shading is right in this area. It's not here. It's not where between the two x-intercepts. That's only blue here. And it's not between the two y-intercepts. That's only orange. The double shading is right here in this section. Okay, so our corner points, we have a few more this time. We have our 0, 0, always 0, 0. We have our blue y-intercept. Notice the orange y-intercept is not on the feasible region. The blue one is, though. So we have our blue y-intercept right there. And then we have our orange x-intercept. Not the blue x-intercept, but the orange intercept is where the feasible region is. So that's going to be our third one. And then the fourth one is right here. Okay, that's our fourth corner point. It's on the feasible region. So this is where we have to come back to finding where the two lines cross, right? So again, I don't care about the inequality. And then I need my orange. Okay, so I can get rid of my y's, my x's by just pushing a negative. Okay, so what I just did is I just multiplied negative, I'm going to do it over here. I just multiplied -1 times this, times this whole thing. That's all I did. I just multiplied -1 through. So -1 times x is -x. -1 times 2y is -2y. -1 times 4 is -4. And now I'm going to cancel the x's. I end up with -y equals -1. -4 and 3 is -1. And then divide by -1. So my y is a +1. Now I'm going to go back and plug this +1 back into either equation, and this is the easiest one. Get rid of the 1, and I get x equals 2. So this corner point crosses at the point 2, 1. Okay, that's where those two lines cross. Okay, so those are my 4 corner points. I found the 0, 0, the y-intercept, the x-intercept that touches the feasible region, and then where the two lines cross. Okay. All right. So now we have one with 3. So you can see it gets more and more complicated. Now, the good news is, I'm going to make this a little bit smaller. The good news is is the process is the same, right? The process doesn't change just because we have, 3 lines, but you have to stay organized. And that's why you want to go through the same process every single time and know why you're doing it, know why you're going through that process. Okay. All right. So here we go. First things first is I'm going to do my restrictions. I need to just enough. Well, I'll put my restrictions in and then I'll come back. Okay, so x is greater than 0, y is greater than 0. There's our restrictions. It's already in the first quadrant, so we're good to go. Okay, now I'm going to pick my colors because I can. Okay, so this one I'm going to do is orange. So I have x plus y less than or equal to 11. This is solid. Okay, I'm going to find my intercepts. So when x is 0, y is 11. When x is 11, y is 0. So I'm going to come here and I'm going to graph it. I need to make this smaller so I can actually graph it. Okay. Excuse me. Okay. So 11 and 11. So we're going to have to go by twos. 2, 4, 6. Let me do this too. 2, 4, 6, 8, 10, 12. So 11 is here. And I'm going to go ahead and write that so it reminds me. 2, 4. We're going to go by twos. 2, 4, 6, 8, 10, 12. So again, there's my 11. There is my line. Where to shade? 0 is less than or equal to 11. This is true. So I'm going to shade down here. Now, the more lines there are, the more messy this can get, right? So that's why using colored pencils really helps. Okay, so now I'm going to do my second one. So I have x plus 5y greater than or equal to 15. So notice my inequalities are different. Okay, it's still equal to, so I know I'm going to have a solid line. I'm going to find my intercept. So I cover up the x and I end up with 5y equals 15. So y is going to equal 3. I'm going to cover up the y and I get x is 15. So I'm going to come over here. There's 11, 12, 14, 15. And again, I'm going to mark it. And 0, 3. So here is my, I believe this is going to be tough. Okay, here's my line. Okay. And then we do our test point. 0 is greater than or equal to 15. This is a false statement. So when it's false and my 0, 0 is here, I don't want to shade there. I want to shade on the other side. So I'm going to shade up. I'm going to go up. So notice where it's starting to overlap. Okay, now we have 2 colors. We have the orange and the purple that's overlapping. So now let's do the third one. Do it in green. So I have 2x plus y greater than or equal to 12. Okay, so I'm going to get my, I know it's a solid line. I'm going to get my intercepts. I'm going to cover up the x and I get y is 12. Cover up the y and I get x is 6. So 0, 12, there's 11, there's 12. Here is 2, 4, here's 6. Connect the dots. And I get 0 is greater than or equal to 12. This is also a false statement. Okay, so again, I don't want to shade where it's where the 0, 0 is. I want to shade on the other side. So I'm shading out here. So where is all three shadings happening? Well, it's happening. I'm going to try and do this without cutting into anything. All three shades are right in here. It's this triangle. If those were straight lines, this would be a triangle right here. Okay, that's where the feasible region is. So this feasible region has 3 corner points. It has a corner point. Let's see if I can do this. It has a corner point here. I'll do an arrow. Here, that is the green and the orange. So I'm going to find the corner points where the green and the orange line cross. That's this one. The next corner point is here. That is where the orange and the purple line cross. So the orange and the purple line cross. Okay. And then the last one is here, where the green and the purple cross. So where the green and the purple cross. So the purple is x plus 5y equals 15, and the green is 2x plus y equals 12. Okay, so we have 3 systems that we have to solve for. 3 different corner points. And that's the only way to find them. You can look at the graph, but the graph should be your picture of what the math says. So in order to get these absolutely 100% right, your math has to be done correctly. Okay, the graph is a sketch, so it's not going to be as accurate as the math. All right, so here we go. This first set, I'm going to get rid of the y's. So I am going to multiply by a -1 through the top. Okay, so now I can solve. The y's go away. I end up with -2x plus x is -x equals -1. So x equals +1. Then I can plug it back in to find out what the y is. So y equals 10. So my first set where the green and the orange meet is at the point 110. That's my first corner point. Is at the corner 110. Okay, now I'm going to do the same thing with the next one. I'm going to push a negative through. So I'm going to do the middle one. I can eliminate the x's. So I get -y and 5y is 4y. -11 and 15 is 4. So I get y equals 1. Now I can plug that back into the original. And I get x, oops, that should be an 11. X equals 10. Okay, so my second corner point is at the point 10, 1. Okay, that's this one right here, where the orange and the purple meet. Okay, and it looks pretty good, right? That's 10 right there. And it's a little bit higher than normal, but it is right in the right spot. Okay, and then the last one is where the green and the purple meet. So again, I can move this out of the way. I can multiply everything, the top one through by -2. So it ends up being -2x minus 10y equals -30. So the x's go away. I end up with -9y equals -18. Get rid of all this over here. And so divide both sides by -9, and I get y equals 2. Now I'm going to plug that back in so I can solve for my x. So I have x plus 10 equals 15, subtract 10, and I get x equals 5. Now, does that make sense? Yeah, well, here's 2, 4, here's 5. X is 5, and y is 2. So this one is at the point 5, 2. So it works. Okay, so that is my third corner point. Okay. All right, so now what we're going to do is I'm just going to fill in the information, and then I want to show you on my math lab, how to walk through the process. So these next two are word problems. So this is just like what we did in class before. We looked at a word problem. We go, okay, we need to pull out some information. It looks big and scary. All right, so what I want you to do is focus on what is it that we're looking at. So we have two types of skis, a trick ski and a slalom ski. And it says down here that x is the number of trick skis, so we're going to call this x. Y is the number of slalom skis, so we're going to call that y. Okay. We also know that we're looking at how much time it takes to fabricate or build the skis and to finish them, get them all smooth. So it says the trick ski requires 6 labor hours for fabricating. So the trick ski is 6, and 1 for finishing. So 6 and 1. Notice I'm putting it in the trick ski column because the trick ski takes 6 hours to fabricate and 1 hour to finish. The slalom ski requires 4 labor hours to fabricate and 1 hour to finish. So again, I'm putting it in the slalom ski column. The maximum hours available. Okay, so think about in business, you only have so many hours a day, you only have so many hours on a machine. There's lots of times that you're going to have to limit the number of hours that you can work on a certain project. So fabricating is 108. That's the most I can use. And finishing is 24. Maybe I only have, 3 employees that can work 8 hours. So I only have 24 hours in a day. Okay, it's set up. You're good to go. Here are your 2 equations. You have 6x plus 4y is less than or equal to 108 because I can't go above 108. And then I'm going to change colors. 1x plus 1y has to be less than or equal to 24. Okay. Now, because we're dealing in a application, we have to have our restrictions, right? We cannot have negative skis or negative number of hours. So we have to keep everything in the positive. Okay, so you're good to go. We're ready. We are going to put in our restrictions. Okay, there's our x is greater than 0. Here is our y is greater than 0. Okay, we're going to set up our 2 equations. So I have 6x plus 4y greater or less than or equal to 108. This is going to be a solid line. I'm going to find my intercepts. So this, you might have to use your calculator. So when x is 0, right? So we're going to cover up the 6x. I get 108 divided by 4 is 27. When I cover up the y, I get 108 divided by 6, which is 18. Okay, so I'm going to come here and graph that. So I have 27 is my y and 18 is my x. So if I do it by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18. So there's my 18. and 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So 27 is right about there. So I'm going to create my line. Shade 0 is less than or equal to 108. This is a true statement. So we're going to shade below. Okay. Now I'm going to change my color. And I get x plus y less than or equal to 24. So hopefully by the time you get to your word problems, you are going to be so good at this. You don't even have to think twice about it. Okay, so we have 18, 20, 22, 24, and then 27, 26, 24 right here. So there's that line. And then we test 0 is less than or equal to 24 is a true statement. So we are going to shade below. So again, we have a bounded region, right? All the sides are covered. We have our corner points. So we have one, let me highlight these. We have 1, 2, 3, 4. Those are your 4 corner points. So 3 of them are easy. We have our 0, 0. We have the purple y-intercept, which is 0, 24. We have, I'm sorry, the pink. We have the black x-intercept, which was 18, 0. And then the last one is where the 2 lines cross. So you do your elimination. So we're going to do 6x plus 4y equals 108. And x plus y equals 24. So I'm going to multiply my x times -6 to get rid of the x. So I end up with 6x plus 4y equals 108. And -6x minus 6y equals a negative. And then what's 24 times 6? 144. So -144. Okay, so my x's go away. I end up with -2y equals 144 minus 108 is 36, -36. So y equals 18. Okay, looks pretty close. And then to find out what x is, I'm going to go back to the original. So x plus 18 equals 24. Subtract 18 from both sides, and I get x equals 6. So my other corner point is 6, 18. So what does that mean in terms of skis? This means I need 6 trick skis and 18 slalom skis in order to either have a maximum or a minimum. And we're not there yet, but that's how we're going to find them. Okay, so this last one, I'm just going to set the table up and then we're going to go into my math lab. Okay, so we have tables and chairs. Okay, tables and chairs. So this is what we are looking at. So we have tables and chairs. Now, how do I know what goes across the top? What goes across the top is what I'm looking for. What's the unknown? So it says, find the set of feasible solutions for the number of tables and chairs. Okay, so I'm looking for X's tables, Y's are chairs, and we have maximum hours. What are we doing with these tables and chairs? We're assembling them and finishing them. So we're assembling them and finishing. Okay, so the table requires 8 hours to assemble, 2 hours to finish. The chair requires 2 hours to assemble and 1 hour to finish. And then maximum labor hours to assemble is 400. And to finish is 120. Okay, so here's your equations. 8x plus 2y less than or equal to 400. 2x plus 1y is less than or equal to 120. And then because we're dealing with actual things, you can't have negative tables and chairs, so you have to have your restrictions. Okay, so I'm going to stop there as far as graphing this. I'm not going to graph this one, but I am going to go into our My Math Lab. Get into the right class here. Okay. So 5.2. All right, so here's what I want you to do. So I'm going to do this on the screen as if I'm doing it paper, and then I'm going to walk through, and I'm going to do it with a restriction. And then I'm going to walk through the actual graphing it on My Math Lab, okay? So again, make sure that you are doing this on paper first. Once you get your answer, then you're going to input it into My Math Lab, okay? So what you're going to see me do is we're going to do this first as if it's on paper. Okay, so here we go. I'm going to, that's right, that's over here now. I'm going to pick colors. Okay, so this is my paper. Okay, I'm doing this on paper, but I'm showing it to you on my screen. So I have my restrictions. Okay, I always do those first. So again, this is my paper. I am showing you on paper how I'm doing this before I ever open my tool, right? Where it says click to enlarge, that's where the tool is. Okay, so there is my restrictions. Now I'm going to use a different color from this first line. Okay, so my first line is purple. So I have x plus y is less than or equal to 6. This is a solid line. My y-intercept is 6, and my x-intercept is 6. So on paper, I'm coming here. I have a point at 6 and at 6. I create my line. I do my test. 0 is less than or equal to 6. That is a true statement. So I'm going to shade below. And again, this is all on my paper. Okay. Now I'm going to do my second one in green. So I have a solid line again. I'm going to cover up the x and I get y is 4. I'm going to cover up the y and I get x is 8. So I come up here, 0, 4, 8, 0. Here is my line. I'm going to use my test point. 0 is less than or equal to 8. That is also true. So I'm shading below this line. Okay, so you can see where it's double shaded. It's double shaded right here, right in this area. All right, and then it says find the coordinates of each point. So the coordinates are your corner points. Okay, so we know we have 0, 0. I have the green y-intercept, which is 0, 4. I have the purple x-intercept right here, which is 6, 0. And then I need to find this corner point right there, where those two lines cross. Okay, so where they cross is, let me get this out of the way, where they cross. So I have the wrong color. I have the green one. I have the purple one. Okay, so now I'm going to multiply a negative through so I can get rid of my x's. Negative 2y plus y is negative y. Negative 8 plus 6 is negative 2. So my y equals 2. And now I'm going to figure out what my x is. So my x equals 4. Now again, I want to look, does that make sense? Well, here's 4. So because my lines are a little wanky, it's going to show a little bit, right? It's going to be off just a little bit. But my other corner point is at the point 4, 2. Okay, so I have it on paper. Now watch what I do. Now I come over to my MyMathLab. I click to enlarge, and I'm going to move this so that you can see it. So that you can see how I'm going to do this. Okay, that's probably good enough because I have all the information over here. All right, so first things first, solid line, pick up the tool, place a point at the x, excuse me, the x is greater than or equal to 0. Again, notice in the yellow, it gives me the coordinates. It's orange, or the line is orange, so I want to click again. Now it's set. I pick up the tool. I make sure it's on the y is 0, doesn't matter where. I have my restrictions. Now I'm going to pick up the tool. I'm going to graph my purple line. So I have 0, 6. Notice the coordinate. I click. I have 6, 0. Notice the coordinate. I click a third time. It's blue. I'm not picking up the can yet. Now I'm going to graph my other line. I have 0, 4, click, 8, 0, click, click again. Now I pick up my paint can. And because I've already done this, I've already seen where it's double shaded. I pick up the can, I place it where it's going to double shade, and I'm good to go. I hit save, I hit check answer, and it's fantastic. Okay, so whenever you're doing these, make sure that you do it on paper first. Then it makes using the tool in MyMathLab much easier. Okay, and then this is bounded. Okay, and this one, it does ask me for corner points. See, on your paper, I already have them done. So it says type each set of coordinates with a comma in between. So do you see how once I'm done with it on paper, it makes it so much easier on MyMathLab? Okay, there's all my coordinates. I'm good to go, and I can do next question. Now, remember, on 4, 1, 5, 1, 5, 2, and 5, 3, it's unlimited access. Unlimited. That means you can do this over and over and over and over and over again until you are super comfortable with it. Okay? All right. That's it. See you on Tuesday.